Hello, and welcome to Settle the Stars. Episode 9, Venus, the Nightmare Next Door. Hey folks, this is Alexander Winn. In this episode, we'll be visiting Venus, our nearest neighbor and one of the most watched objects in our sky throughout the ages. In our journey, we'll learn about some of the strangest and fiercest conditions our solar system has to offer. Scorching heat, crushing pressure, dueling hurricanes, and acid rain. We'll find out about the latest in the search for alien life in this hellscape, and learn about the pivotal role Venus has played in some of the most important discoveries in history, and the fascinating lessons she continues to teach us about our own home on Earth. To us here on Earth, Venus is not some faraway, unknown world. When we think about it, we don't need some special mnemonic device like we do to remember the moons of Saturn, or a special code designation like we would use for the thousands of comets buzzing around the sun. It's right there in the sky, a familiar bright star clearly visible from just about anywhere on Earth. In fact, before you even knew what a planet was, you might have even wished upon it with the popular poem, "Starlight, star bright, first star I see tonight." As the brightest object in the sky after the sun and moon, it's no wonder at all that Venus has captured our attention the way it has. Throughout history, Venus has been the subject of interest and inspiration for us here on Earth. Because Venus is closer to the sun than us, it never strays far from it in the sky, which explains why it's visible in the morning or evening when the sun is just below the horizon. It also follows a synodic cycle in which the planet becomes invisible as it gets near the sun, and then appears again on the opposite horizon on the other side of the sun. During this cycle, the planet can be observed quite high in the sky, but it never quite reaches the apex. These interesting features stirred the imaginations of early stargazers who told stories about the gods and goddesses they associated with Venus as a way to explain these observations. The disappearing act that Venus performs, visible for a time in the morning and then switching to the evening as the planet passes Earth in its orbit, was of intense interest to many ancient cultures. Many interpreted the phenomenon as a god with two balanced aspects, or explained the temporary disappearance, which lasted about 3 days, as a divine journey to the underworld. The ancient Mesopotamians, who lived in modern Iraq, named the planet Inanna after the goddess of love and war, balanced aspects of life and death. They recorded stories of Inanna's journey into the underworld, her death and rebirth, to explain the disappearance of the planet from the sky. In fact, many details of Inanna's saga, from her journey to Kur, or the mountains of the west, to a heavenly search for her enemy, can be linked to the movements of Venus in the sky. Across the globe in Vietnam, ancient stargazers believed the morning star and evening star were two separate entities. Folklore tells the story of two separated lovers, Sao Mei and Sao Hom, destined to search for each other and remain apart forever. In classical Roman mythology, Venus was known as Lucifer, or Lightbringer in Latin, in the morning, and Vesper in the evening. This mythology carried over into the Christian stories of a fallen angel who was punished for attempting to climb too high within heaven, another link to Venus's path which approaches, but never quite reaches, the apex of the sky. That ancient myth about the planet was adopted elsewhere by Christians, appearing again in the book of Revelations, in which Jesus refers to himself as the bright morning star. Interestingly, according to the story, Jesus eventually undergoes his own 3-day period of death and rebirth, celebrated annually as Easter. But perhaps no culture was as intensely devoted to Venus as the Mayans. Among the Mayans, Venus was known as Chak-ek, the great star. To them, Chak-ek was the single most important celestial body, even more so than the sun and moon. Their calendars meticulously recorded the movement of the planet and predicted its activity over a period of thousands of years with a margin of error of just 15 minutes. The Mayans believed Chak-ek influenced the activities and quality of life on Earth, and all major events within the empire, including war, were carefully timed to coincide with the position of the planet. All these cultures and more all over the world, too many of them to mention, were enthralled by this morning star and the mysterious order of her movement across the sky. By observing, tracking, and recording Venus and the other planets as meticulously as they did, a general understanding and appreciation emerged for astronomy. This, in turn, advanced our understanding of the physics, optics, mathematics, and geometry necessary to successfully observe the stars, leading to even more discoveries. More recently, Venus contributed to Europe's domination of the globe during the Age of Exploration. Back in the 1700s, the seafaring nations were busy colonizing, waging war, and trading all around the world. But even with their new expertise and expensive warships, a seemingly simple question of navigation confounded them. How can a sailor accurately measure his location on the planet when he's gone beyond the edge of his map? How far north or south of the equator a navigator is, also known as latitude, can be identified relatively easily by measuring the angle of the sun at noon. But identifying location longitudinally, or how far east or west you've traveled, is a much more difficult problem that led to some tragic and embarrassing shipwrecks at the time. It was believed that having an exact measurement for all of these navigational references, the distance from the Earth to the Sun, the distance to the planets, the size of the Earth itself, and so on, would contribute to a solution and provide an answer to the question of navigation. And as it happened, a rare astronomical event, the transit of Venus, would provide an opportunity to capture all of that information. The transit of Venus is the name for the special alignment of the Sun, Venus, and Earth. During this event, an observer here on Earth can witness Venus as it transits or travels across the face of the Sun. Astronomers in this period realized that by measuring the length of time it takes for Venus to pass between the Earth and the Sun from various vantage points across the globe, all kinds of information could be calculated. The size of the Sun, Venus, and Earth, for starters, as well as the distances between each of them. The scientists realized they would only get 2 shots at this, because transits of Venus are a twice-in-a-lifetime event. The orbital cycles of Earth and Venus produce a pair of transits about 8 years apart, just once a century. So expeditions were prepared around the world in one of the first international scientific endeavors to record the transits of 1761 and 1768. The transit of Venus in 1761 was an excellent trial run. The expeditions included a new team of astronomer Charles Mason and surveyor Jeremiah Dixon, whose excellent observations would make them famous enough to be called upon later to settle a land dispute in North America by establishing the historic Mason-Dixon line. But the second transit in 1768 was the main event, with observers spread out from the Arctic Circle to the South Pacific. A special scientific commission from King George III placed Lieutenant Captain James Cook in command of the Endeavour to lead an expedition to Tahiti. And after a successful observation of the transit of Venus from the southern islands, Captain Cook steered his ship westward to eventually reach the mythical Terra Australis Incognita and claim the continent now known as Australia for the British Empire. You can see how, even as an object of curiosity and inquiry, Venus has played a major role in the shaping of our collective human history. Major advances in the study of physics, astronomy, and mathematics were made in our attempt to better understand the planet and how it related to our own. And the pursuit of those advances had impacts across every other field of human endeavor. Over the centuries, as telescopes became more advanced, we would observe that the entire planet of Venus is permanently engulfed in thick clouds, a rarity among the rocky planets of the solar system, which spurred imaginative theories and fictions of advanced civilizations living and breathing just like us. But once we got a closer look with the help of satellites and probes, we began to realize how unlikely that was. Since 1961, 42 missions have attempted to explore Venus, with the first successful flyby in 1962 by NASA's Mariner 2 probe. The first ever successful landing on another planet was achieved by the Soviet Venera 8 lander in 1972. While the data returned from the Venera 8 was limited, subsequent landings and flybys painted the picture of a planet far different from the bright and jubilant morning star celebrated by so many cultures around the world. These early observations depicted a hellscape. An atmosphere dense enough to crush a steel spacecraft raged in a perpetual tempest at the poles. Where scientists hoped clouds might offer life-giving rain, almost no trace of water was found. Instead, corrosive sulfuric acid was found in abundance, and with the toxic liquid actually raining down from the sky at higher altitudes. Soviet scientists described a cloud-choked sky as dark as a cloudy Moscow evening, and across every surface, infused in every gust of caustic wind, was an astonishingly intense heat. It became clear that any life here would be having a rough time of it, and by the 1970s it was clear that complex life on the planet would probably not be viable at all. But scientific debate continues, even today, on whether the atmosphere might support colonies of extreme bacteria or similar organisms. Evidence for life continues to be sought within the data collected so far, but definitive confirmation will hopefully be provided by one of the 15 future missions currently being developed by various agencies worldwide. So, what does all this mean for potential human exploration? How would an explorer experience these conditions firsthand? By compiling our observations so far, we can make a pretty good guess. Step 1 for explorers of new worlds will probably be to say goodbye to friends and loved ones, doubly so for the first visitor to a world as dangerous as Venus. Not necessarily because space exploration is a suicide mission. Scientists and engineers will do their best to keep you safe after all. But because early manned voyages might not come with a return ticket. Fuel and repairs are tough to come by without infrastructure, and the thick atmosphere of Venus will require an immense amount of thrust to get any surface craft back into orbit. So, the first explorers may have to become permanent residents to pave the way for future visits. Fortunately, Venus is pretty close to Earth, a mere 24.8 million miles at its nearest approach. But it's never a straight shot between orbiting planets. As the saying goes, there are no straight lines in space. The quickest trip to Venus so far was accomplished by Mariner 2 in 1962, which spent 109 days en route. It's probably safe to assume a trip will take around 120 or 130 days, or about 4 months. In terms of space travel, that's a very quick commute. If you manage a full night's rest all along the way, you'd only be left with about 2,000 hours worth of time to kill. Assuming any interplanetary explorer worth their salt is a fan of Star Trek, you'd have enough time to watch all the feature films and every single episode from every single TV series 3 times before arrival. But sadly, you probably wouldn't get the chance to finish that marathon. Your waking hours will be more likely filled with exercise to keep your muscles and bones strong as they become accustomed to weightlessness, patching up the occasional damage caused by a stray piece of debris, or conducting experiments to make future long-term space travel easier for future explorers. So, maybe you'd only get to see Captain Kirk save the whales once or twice. Bummer, I know. But the real work begins once Venus is in view. The first task will be determining a final position to bring the spacecraft in for landing. Beneath the clouds, the surface is generally rocky and uneven just about everywhere, so the main consideration will be weather. The clouds will obscure your view of the sky anywhere on the planet, but the equator offers less wind, which is no small consideration. As far from the poles as you can get is usually where you want to be on Venus. Scientists were mystified to discover that both the north and south poles of Venus are crowned by intense storms unlike anything they'd seen before. At each pole swirls a violent double vortex, each of which churns like 2 hurricanes here on Earth circling each other. The South Pole has been better observed, where the combined size of this huge storm is estimated to be as large as Europe, with wind speeds over 300 kilometers per hour. Most of the wind at that surface level is composed of carbon dioxide, which makes up 97% of the atmosphere, and most of the rest is nitrogen. And the air is much, much denser than here on Earth, about 90 times as dense. The air is literally thicker than seawater on Earth. So if 300 kilometer an hour winds doesn't sound all that bad to you, picture an ocean wave hitting you in the face at 300 kilometers an hour. And don't forget that the wave is almost 900 degrees Fahrenheit. If it's all the same to you, I'd suggest we land closer to the equator, where wind speeds are usually down to about 5 kilometers an hour. Where most spaceships are built to hold pressure in, our landing module will be reinforced like a submarine to counter the intense exterior pressure of the atmosphere once we land. Even just touching down on a hill on the surface of Venus is the pressure equivalent of diving 3,000 feet underwater here on Earth. And while most submarines on Earth aren't bathed in sulfuric acid before they carry people below the waves, there's no way around it here on Venus. The thick clouds covering the planet are almost entirely composed of corrosive acid, so our lander will have to be protected to ensure we continue to withstand the pressure and heat as we descend. And boy, is it hot. Venus has the hottest temperatures in the solar system outside of the sun, thanks to that thick blanket of clouds. Our poor landing module will need to protect us from temperatures hot enough to melt lead, about 880 degrees Fahrenheit. That's 470 degrees Celsius. But hey, at least we won't get zapped by lightning. Probably. The clouds do appear capable of producing lightning, just like on Earth, although no strikes have been directly observed yet. So, that's good. But here we are at last, safe and sound on our own little slice of hell. We survived the wind, the acid clouds, the scorching heat, and the crushing atmosphere, and we have landed on the surface of Venus. So, now what? I don't think a little sightseeing would be out of the question. We did just travel quite a long way, after all. But if you're waiting to see what a sunset looks like beneath the churning clouds of Venus, you might be waiting a while. A single day on Venus is as long as 243 days on Earth. That's the slowest rotation in our solar system by a long margin. In fact, a day on Venus is longer than a year on Venus. It takes longer for the planet to rotate on its axis than it does for it to go all the way around the sun. And not that it will make much of a difference from under those thick clouds and sulfuric acid haze, but the sun will actually set very, very slowly into the eastern horizon instead of the west. There won't be different seasons to speak of like we're used to on Earth, so no need to plan a different outfit for the springtime. You'll find your ultra-protective suit to be conveniently stylish year-round here. A supercritical sea of carbon dioxide at ground level would probably make walking outside feel like you're trudging along underwater, but at least the thick atmosphere will keep us cozy as a pot in a kiln throughout the long night. On second thought, it's probably best to get back inside. Safe within our surface submersible, we can turn our attention to observation and experimentation to attempt to unravel some of the other grand mysteries Venus still holds. For starters, as we look up into the toxic, roiling clouds, how has the atmosphere changed into this incredibly hostile state? There are a lot of unexpected peculiarities about Venus's sky for us to consider. For example, its composition. Venus is 95% the size of Earth and has a very similar composition and location in the solar system, and yet the air of Venus is highly enriched with noble gases as compared to Earth. Does this hint that planets formed from very different primordial nebula compositions despite their proximity? Or perhaps a large comet impact delivered the gases in some later collision? There are probably a ton of clues to be found within the craters and rocks of the Venusian surface to help support or discount these theories, but maybe you should go look first. I'm fine here in the lander. And what's going on beneath our feet, anyway? What lessons can we learn about volcanism and plate tectonics? What evidence can we find beneath the clouds that are impossible for our telescopes and probes to see from above? It is clear that volcanoes once covered the landscape. In fact, there are many times more volcanoes on the surface of Venus than on Earth, and many of them are larger than the largest here on Earth. Maybe without the continuous cycling of crust that the Earth undergoes, the Venusian volcanoes simply last longer, shielded from erosion and impacts by the thick atmosphere? Erosion does seem to work differently on Venus. On the occasion that an object manages to punch through the thick Venusian clouds, it makes a crater just like you would expect. On Earth, such craters are worn down by wind and rain, and on a world with no atmosphere like Mercury, the craters are gradually erased by other craters. But most of the craters on Venus appear to be in pristine condition. Paired with the high number of well-preserved but quiet volcano calderas, these observations support a prominent theory that Venus underwent a globally catastrophic resurfacing event sometime around 300 to 600 million years ago. Maybe in contrast to Earth's gigantic conveyor belts of planetary crust being generated and subducted, Venus alternates between long periods of geologic calm, gradually building temperature and pressure until everything is released in a massive, planet-wide chain eruption. You know, maybe I should just recheck that our escape pod is working correctly. And speaking of erosion, where has all the water gone? With such an abundance on nearby Earth, surely there would be traces of water on our twin world. One hint lies in a curious detail. Venus lacks a large, internally generated magnetic field, like the one Earth has. Instead, its much weaker magnetic field is induced as an interaction between the outer ionosphere as it collides with the solar wind from the sun. as opposed to Earth's internal dynamo generated by convection currents in the mantle. Not only is this more evidence that the internal workings of the planet differ from Earth's, but it also helps to explain the lack of water. Without a protective magnetic field, as the heat of Venus rose and the water evaporated, it was gradually blown away by the solar wind. There are many differences between the Earth and Venus, but the lessons from Venus are invaluable in one important, deeply concerning area: climate change. Evidence shows that in the past, Venus was likely quite different from its modern hellscape, with its current state resulting from a drastic runaway greenhouse effect. Whether the effect was initiated by some specific geological event or gradually snowballed from its initial composition is still in question, but the very real and profoundly serious effects of these processes is definitely worth studying. If we could learn more about what happened to Venus, it could help us prepare for the consequences of our actions here on Earth. Of course, to encourage future expeditions to the planet, it will fall to us, as the first explorers on Venus, to make sure that the people that follow find more comfort and access than our little lander can provide. One promising idea is to take advantage of the thick Venusian air and sail over it in a great airship instead of sheltering on the surface at all. A container of air, as we would find it on Earth, would be quite buoyant on Venus, which has caused some engineers to envision entire cities floating above the clouds to continue studying the planet from above. After all, people sail in ships over the water all the time, and with an atmosphere thicker than seawater, it might not be so different on Venus. At the end of the day, a valuable takeaway from our visit to Venus is that even after the dozens of successful probes and lander missions, an impressive array of sensors and massive amounts of data, and centuries of observation by sky-gazing humans, our nearest and most similar neighbor still holds so many questions yet to be answered. Next to the farthest and strangest space anomalies detectable from Earth, it can seem like the book on Venus has been written and closed already, but nothing could be further from the truth. I hope you enjoyed this visit to our sister planet. Far from just a pretty light in the sky, Venus is a planet of awe-inspiring drama and incredible potential. Next week, we'll continue our journey to another planet that humans have been dreaming about for centuries, this time on the other side of Earth's orbit, the focus of millions of would-be space explorers and the future home of humanity, the red planet, Mars. In the meantime, be sure to subscribe if you haven't already. Settle the Stars is available on pretty much every podcasting platform, and we're also mirroring our episodes to YouTube at youtube.com/edgeworksentertainment. And be sure to ring that bell so you know when there's a new episode. And don't miss the other awesome shows that are part of the Edgeworks Nebula: Slice of Science, The Synthesis, and our upcoming show You Have My Sword, where Christy Pride will be analyzing and deep diving into the world of Lord of the Rings and J.R.R. Tolkien's Middle-earth. Thank you all for listening, and as always, happy terraforming. Settle the Stars is a proud member of the Edgeworks Nebula, a collection of intriguing and informative podcasts from Edgeworks Entertainment.
Edgeworks Nebula.